Yep. All right. Hey, welcome everybody. Hopefully you're here for, what did I call this? Practical Low Effort PCG. You may be wondering why there's fashion on the screen at a roguelike. This is because this language that I've made, rather accidentally, as I'll explain, it's super general purpose. I've used it to make recipe generators, fashion, socks, Valentine's Day cards, spaceships, weird, surrealist, gay erotica, a wide variety of things, and in fact a couple of like little self-playing RPGs as well. I'm not showing those here, but ask me later, I can show you how to reskin some interesting RPGs using Tracery. So yeah, practical low effort PCG, or how to do procedural content generation without making your life really, really difficult. So about me, I'm Galaxy Kate on all the things, Twitter especially. I've made a ton of generators. I was one of the major people making the planets on Spore, if anybody played Spore back in the day. I've made dance generators and skeleton generators and weird flower generators. I'm getting a PhD at UC Santa Cruz in this, in the Expressive Intelligence Studio. And some of you may know me as the person who wrote a well-liked introduction to generators. So you want to build a generator, which is 4,000 words written in 2 hours at Starbucks. Coffee, you guys. Yeah. So my history with roguelikes, I didn't play as many roguelikes as most people. I still haven't played Dwarf Fortress. I mostly play the read-throughs. But I did make, my one claim to fame with roguelikes is that I made the only roguelike published by Maxis, officially published by Maxis. This was the Dungeons of Spore 2009 April Fool's Day joke. This is a PCG roguelike where you wander around, and all the creatures that you meet were slurped from the Sporepedia, which is all the creatures that people had uploaded. So this is a roguelike that uses as its generation engine a major AAA game. So that was fun. Although I did play a ton of this. This ate my childhood. This is anybody having flashbacks. This is and trying to get that like cloak up there. This is Castle of the Winds, which is like the roguelike of my childhood. But many of you may know me, and the reason I'm here speaking is because I made the Tracery library. And that's the first part of what I'll be talking about to you today. And like, hopefully you have a zine. If you don't have a zine, borrow it from a friend. But the way that this library works is, maybe some of you were in the Kingdom of Loathing talk earlier today. That whole thing where they made like a templating text system. I made a templating text system so that nobody has to make a templating text system anymore and like take that journey. You can take that journey on your own. It's cool, but you don't have to now. So what you do is you write a little like grammar. You feed it through tracery.js. Maybe it can spit out some infographics if you like that sort of thing, but mostly it spits out generated text. And people have ported this to a wide range of languages. I think Python, Ruby, Unity, Twine, there's a bunch. And people are porting it to many more. So it was originally actually a homework assignment for Michael Matthias's interactive narrative class. If you don't know Michael Matthias, he's my advisor, but he's the guy who made Facade, yeah, which is now like interesting on Twitch after like 10 years. I put it online on GitHub. And then somebody sent me a tweet that said like, hey, this guy has made this thing that's hosting Tracery grammars and basically making a one-stop shop for building your own Twitter bot. So there's, I think, between 500 and 1,000 Twitter bots currently running on Cheatbots Done Quick. I have literally no idea how many other bots on Twitter are using Cheatbots Done Quick. These are a couple of my favorite ones. The ThinkPeas bot, which is incredibly popular. Hipster Cocktails, which makes really terrible hipster cocktails. Deep Space Probe, which makes sort of melancholic poetry about being a lost probe. And yeah, this is really taken off. So this is, I bring Tracery here to the roguelike in the hopes that people might find it interesting to use in roguelikes, but it turns out it's like really the Twitter bot language. And recently George did an update where now you can respond to these Twitter bots. This is possibly my all-time favorite bot. It's called Endless Screaming, and it endlessly screams. But now you can hold conversations with it, and I really enjoy the conversations. And if you encourage a friend to go to Endless Screaming will butt in and endlessly scream at you. This is another one that Jason Greenblatt did, who I don't know if he's here in this room or in the other room. I think he's speaking today. But this was for Fermi Jam. This is actually using these bots and their ability to communicate with each other to have two little space probes that are lost in space trying to find each other as like a metaphor for romance. And they generate hashtags that probably aren't being used and try to find each other on these hashtags. I know, it's beautiful. And he said there's almost no chance that they'll ever communicate, but if they do, they can say hi. And so I really like this one because it's using Tracery not just as like a text generator, but using it as kind of like a generator for situations or a generator for some sort of meta information. There's another really wonderful one by Emily Short, who made a Tracery bot that there was all of the IF stuff that's online. There's a search engine that you can search for IF where interactive fiction works, if you have, like, you could actually structure a link to have a valid query in it. And so she made things that are just like, click here for, interactive novels about coming of age in Sweden. Click here for time travel-based things that do interesting things with nouns. So like things that are mostly empty queries, but sometimes aren't. So that was kind of another neat meta one. It's also for games. I was extremely lucky in making this language that as I made it, the person who was my roommate was also an incredible interactive artist. That's Dietrich Swinkerfer, and they were my first big user, and they made a ton of games that are amazing games that use it for different generative text things. This one generates different, sadly I don't have working animated GIFs here, but this one generates different ways to greet your partner. This one is you're at a dinner party with friends, and they're talking endlessly. They're just like spewing endless information about what their friends have been doing on the weekends, and you interrupt them to talk about the games that you've played. And you have to talk, neither of you can listen to each other, but you both have to talk enough that neither of you fades from the conversation. It's melancholic. Fitzwilliam Darcy's dance challenge, as you're like badly trying to dance with Mr. Darcy, he insults you. And then the latest one, which somebody actually pointed out to me, uses Tracery just because he had gone into the source code and actually looked at it, is Pippin Bars. It's as if you were playing chess, where it projects little chess moves onto the screen, and you're supposed to look at the screen in different ways and then like nod and then frown and then move the piece. Yeah, and then I've done a bunch of my own work. The fashion one is entirely Tracery generated. This one is also entirely Tracery generated. This is based on a Twitter bot that I made, but you can also have these little ships that become SVGs on an HTML web page and fly around, and each one of them is telling you kind of different stuff about the person who's riding in this ship. Like, it's been commandeered by a green-winged sun girl and a terrifying princess on spring break. Things like that. Flown by a divine punk looking for trouble and a well-adjusted navigator running from their past. Little Firefly generators. And then I wrote this one. This is a friend had sent me some of Chuck Tingles' work before Chuck Tingle was cool and challenged me to do a Chuck Tingle generator. So this one has been, I keep meaning to work on this more. It's a procedural dating game that is basically Chuck Tingle in space in a time-traveling bar. And then this is the latest one that I've been working on. This is Hip Chef. It's a hipster chef game based on San Francisco brunch, where you come up with you get increasingly bizarre recipes, and they become hip depending on whether or not their ingredients are cool. So when duck fat becomes cool, you strip out all the kale in your menu and you fill it with duck fat and coriander soda, which is something that it generated for me once. So yeah, that's Tracery. If you want to generate some text, use Tracery, or don't, But what it actually looks like is kind of this giant, so this is the patron generator for Hip Chef, because your NPCs are basically like people who come into your cafe and bring strange stories with them in their descriptions. And I really like that this is the part of my work that feels most roguelike-ish, even though it's not at all about like wandering a little dungeon in ASCII art. It's giving you text that makes your mind tell stories. And this, for me, is like one of the core ingredients of roguelikeness. It's just like sketching out text and making your mind fill it in. So these are some of the things that it came up with, like a hungover truck driver with mud-covered shoes, a nervous nun with haunted eyes, a tanned clown in a black bathrobe, a pair of ashen-faced ballerinas. It makes you come up with stories. The best one I ever got, hands down, is an angry nun in a wedding dress. And she came in and ordered a glass of Chardonnay, and then she was gone. But But this is what I find really fun about this is like, you know, yeah, it encourages you to write just a ton of text. And this is why I said painless, or like why I called it like something like painless PCG in my title, is I wrote this language such that you can write a ton of stuff and it's not hard. If I had to write if statements for each one of these, I would not have written this much text. It encourages you to just do like a ton of this sort of thing. Yeah. And so why is the fact that I use JSON important? And this talk is kind of like about data structures. Who here is a coder? Who here can like barely code? Who here cannot code at all? Cool, a little bit of everyone. This is sort of the like, hi, I'm from academia talk given to people who are indies or just starting out or even are quite sophisticated about the things that you learn in computer science grad school which are actually worthwhile, which is mostly algorithms and why algorithms make your life better. Because you could do a lot of things in a giant chain of if statements, but if you use JSON instead, there's things like it copy-pastes really easily, so I can just copy large sections of somebody else's stuff and paste it in. It can be linted. There's a JSON linter online that will tell you where your problems with your JSON are, which is kind of nice. It's safe-ish to run arbitrary code. So George Buckingham is just running a node server, and he runs any damn piece of Tracery you send it, which Jacob has tested. I think you're the only person who's trolled it yet. But it's able to run like 500 strangers' Twitter bots, and he never has to restart the dang thing. Try running that with arbitrary JavaScript code that somebody sends you, and I do not recommend that. It's easy to write, edit, lots of content, just like a ton of content. It's very similar to the system that was presented in the Kingdom of Loathing talk today, where it's just like a templating language, and you can see that like there's like person suit is in hashtags.a, which means you find the person suit, fill it in, and then you correctly add a or an to it. But most importantly for this talk is it formalizes the thing that you had probably written on your own. I had written versions of this before, like for the Spore one, and it turns it into a reusable utility. And this becomes strangely important. So yeah, fuck yeah, that's the goal of this talk, is like do this with more things and your life will be better. So frequently when you're developing a game, this sort of thing happens. Games are really hard to make by themselves. Like there's all sorts of things that go wrong. They require a lot of custom behavior. They require a lot of content, especially if you're doing roguelikes. Each piece of content requires lots of custom behaviors on its own. You know, if I use the axe, make a sound that says splat. If I use the hammer, make a sound that says doink, whatever. And it just becomes a code nightmare. And so I'm encouraging you to stop when you see this happen. You know, you may have seen the Kingdom of Loathing, like giant chain of if statements earlier. If I could have changed my slide then, I would have added that here. But if you have a giant chain of if statements, that's when you want to stop and think about data structures. Because you're going to have something that looks like this times x pieces of content, or worse, times x, or worse. So I call this the don't whittle your own screws philosophy. Indie game developers are forever whittling their own screws. They'll have something that's like, I need to attach two objects together, and they'll go off and like make a custom piece of hardware that attaches those two things together. And then later when they want to attach two other things together, they'll like hand whittle another screw that does that. And you're just forever whittling screws. So instead, you know, a lot of content requires pretty standard behavior, so make a standard data structure for it, or better yet, find one. This is what's great about academia, is that it will tell you lots of different stuff like that. And then author as many pieces, like author that into static data structure, and then interpret that into logic by a well-built, well-tested interpreter. Because you're only building one of these, you can actually build it well and test it well. So Tracery is like really quite stable at this point, in that my hand-carved screws would not be that stable. So there are a lot of examples of this that have been found very useful by people. So Tracery is a really good example of like, you know, I want to expand stuff out in a templating way, in a recursive way, which in computer science is called a grammar. There's tons of stuff on grammars, but I made it into like a mass-produced screw. So hypertext is an established genre, like clicking on things to get to other things. It's been around since Lord knows when, somebody can tell me. Nick Montfort can rattle off dates. You know, you need like nodes, text, and how to move between things by clicking. So if you make a data structure of this and a thing that parses and interprets it, you get twine. And suddenly lots of people who would not have whittled their own screws are actually like assembling your IKEA furniture and using it to make the things that actually matter to them. So that's been great. The goal is to make big structures without writing custom code for each one. And Twine has allowed people to make immense structures without writing if statements, or writing the if statements that actually matter. So for example, what is an object in Sims 1? Sims is a really good example of this because here's some things that are issues with, or like, these are the things that comprise an object in Sims 1, which is the last one that I actually know any about the data structure. It's got 4 images and a footprint size. It advertises needs. It activates an animation, and then when you're done, it increments some needs. And so you can make endless objects without writing custom code for each one. So they can release, there's Katy Perry expansion that they released recently, which is just we're not going to change the code, so we're not going to need to debug endless stuff. We're just going to add some new objects. It also adds some really neat mnemonic possibilities. So I don't know if anybody ever played The Sims 1, but there was a smoking table that somebody had made as downloadable content that took advantage of the chess table where you could sit down and play chess, and it did this sort of thing. And they replaced that with the smoking table, so it will look like that you were doing this with a cigarette. They realized that these two things don't actually need to be true. So the smoking table advertised that it would make you less lonely, but didn't. So you can get people, if you have a good data structure, people will find new ways to make it do things that you didn't realize it could do, and usually be very expressive with that possibility. So yeah, who wants to learn the secrets of AI from somebody who's getting a PhD in it? I'm also part of the Game Programmers Guild, which is a secretive organization that does not give out long hooded robes, I asked. So yeah, the secrets of AI. Not writing if statements. You will write some if statements, that's okay. But if your if statements get if your indentation goes this long, don't. It's coming up with a set of really good reusable data structures, the IKEA set of stuff that you run into all the time. You'll still have custom stuff, there's always custom stuff, but it can implement commonly needed kinds of behavior. And those of you who are experts may know a couple of the ones that I'm going to describe in a moment, but learning to recognize them in the wild is really great, or because then you can either find tools that people have built, like Tracery, or you can at least build the right tools to deal with them. And you're not just discovering that you've attempted to build a space shuttle when you thought you were only trying to build a ladder. So this is the finite state machine. It's basically nodes that have connections between them, and whether or not you can move between the nodes, there are different sets of rules. Things like, if something is locked or unlocked, it's I have a chest that is locked, and if I have the key, that can move from locked to unlocked. Or, I have n hit points, and when my hit points are 0, I have moved from alive to dead. And even things like game state, whether or not you're in the save menu, how menus are connected together. Most website navigations is a giant, finite state machine. And the interpreter here is kind of the hero, because it's keeping, it's actually, you have one thing, one director that's keeping track of whether everybody else's state should move, or you have maybe different sets of interpreters who are keeping track of different things. It's not every treasure chest needs to be checking whether or not every frame needs to update. Hypertext in Twine is actually a finite state machine, a subset of it. So once you learn finite state machines, you'll notice that everything is a finite state machine. And so are Markov text generators, mostly. Computer scientists come at me. Certain people will quibble about that. Decision trees. It turns out that one of the cool things that you can describe by data structures is actually AI for stuff. These are the ultimate giant chain of if statements. If my health is low and I have a healing potion and the monster is more than 3 feet away and it's Tuesday, take the healing potion. But if you can represent that abstractly, you can actually get new benefits. And this is one of those things that's look up the relevant literature, decision trees. But you can get things like logging stats, how often do people drink the potion? How did they get to that path? If there's 5 different things that would make the monster attack and you're not sure why the monster is attacking, you can actually log how, which paths they take through the chain and notice that everything is actually getting the aggro or is having a bad day flag set. And you don't have to just play through it 100 times. You can actually evolve and modify trees. You can do tree-based machine learning. So you can actually learn better trees. You can evolve trees. You can say like, these 5 monsters came from the like tiger school, but some of them are going to have their trees modified slightly so they actually make slightly different decisions. And you can do that by like changing whittle branches. And then there's like really hella fancy things like decision forests, which are a real thing, automated decision tree learning, that like once you have this data structure, then you can at least even think about those sort of things, whereas like, I'm going to machine learn my giant chain of if statements? No, thank you. This is kind of an oddball one that like the Expressive Intelligence Studio, we do a lot with this, but it really hasn't gotten outside of academia yet. Adam Smith and Kathleen Toot are like the 2 experts on this, so if you can look them up. There's even one, well, I'll explain what the problem is first. So you know how if like you have a situation where A, B, and C already exist, pick a D such that some constraint is true. Like I have this map generated and I want you to place the like treasure such that it's at least 50 units from the entrance, but it's at least 50 units from the exit. This map generation speed run with answer set programming, it's an article where he basically goes through step by step how to make an incredibly constrained ASCII map generator. With all sorts of different constraints, even such that like you must have walked past the key to the exit before you get to the exit, or like you must not have walked past that. Yeah, like the core of this is that PCG has constraints, but it's incredibly hard to implement those in an algorithm. You end up just like generating a ton of stuff and throwing out half of it, or you end up just like neutering your generator until like it just generates a straight line because that's the only way I can get it to actually go to the exit. And yeah, this is like fancy stuff, but there are automated constraint solvers. Klingo is the one we've been using. They're hard to learn, but writing your own can be worse. There are a couple of games that have actually ended up, Storyteller, discovering that what they were really doing is writing a constraint solver, and then they spend 3 years. And what you really want to do is get the one that like a bunch of PhDs in Germany have spent like 100 PhD years like carefully tuning. It wasn't for games. Adam Smith just like had a math background and found it in like the math community and then brought it over. So yeah, here's kind of a bonus round. So that was a couple of like AI type situations that have screws already designed for them. Here's one of the reasons why it might be good to do that. Even if there's not like a concrete thing that already exists for this, you can visualize your game's logic. So this is not actually a game. This is an AI visualization for a game that Jacob over there and Aaron, who might be in here somewhere, made. But they had a game that was about procedural storytelling, and there's a ton of combinatorics. And how do you find out if here's the content that I've authored, and here's the situations that the content can like cross-pollinate? How do you know if you've actually got coverage of all the stuff that you've written? So they made this like brilliant thing that actually, I don't know if you can see there, it's like problem, not problem. And so you can see like the areas in your game that have high or low problems to not problems ratio. There's also some other really cool stuff coming out of academia as well. PCG, it's really hard to understand the space of the stuff that you're generating until you just like hit refresh 1,000 times. But what if you like tune one thing? Are you now like hitting refresh 100,000 times more and trying to see if that increased the level of trees in the level? Instead, people like Gillian Smith and Michael Cook have been making automated tools to show you the expressive space, which is their term for what kinds of things your level generates. So you could actually like map things like, so for, tuning value A and tuning value B, and I want to see like what the Gillian stuff is for platformer levels. Like what is the difficulty of my platformer levels as I change these tuning things? And you can actually see that like, oh, like, there's like a blob over here and there's a blob over here. And then if you change those tuning values, you can see that the upper blob goes down. And you can even like say like, well, okay, now I want to produce this generator, and I'm going to slice off this bad section, I'm going to slice off that bad section, slice off that bad section, so you can actually like sort of curate the content that's being produced in a way that's sensible. Yeah. So now the real secret of AI. So now that I've given you all the like pretty algorithms and told you how to like standardize all your stuff, and it's all going to be so squeaky clean, and you're going to have no headaches, and everything will fit so nicely in this wonderful little box you've carved for it. Horrible hacks happen. 90% of everything is a special case. The more interesting the world gets, the more interesting your special cases, more interesting and common your special cases get. If you're making chess, your special cases get less. If you are making interesting stuff with all sorts of weird generated things, and like you want to have it do something funny on the 4th of July, it's special cases forever. So yeah, they will always exist. Plan around them. The more complex a program is, the more likely that any given piece of content will have special caseness. So this is like the sort of shameful secrets, is like sometimes you can multi-purpose your generators to do different stuff. So I have like the recipe generator for my hipster chef game. I want different, like I want fennel to be able to become cool, and for a recipe to detect whether or not it has fennel. And like that's cool if the generator like generates that it has the word fennel. That's cool. But like I want it to know that kumquat is citrus and that honeydew is melon, so that melon and citrus can also become cool. I want somebody to be able to say that their restaurant is vegan and we're not going to have anything with poultry generated, or it's like kosher and we're not going to have any bacon. And so how do I like actually tag all that information? I could make bigger data structures, but that's gonna suck. Like that's gonna make me have to author a lot more stuff. And instead I just do little HTML tags, and after it's generated, I like put it through the grinder, strip out all the HTML tags, and like separate the tags from the like pretty content. And that way I have nicely tagged content with having to do the minimal amount of typing. I do believe this is the absolute minimal amount of typing for telling the system that like ducks are poultry and duck. So lessons, if you design your data structures to be flexible and bend to new purposes, this means users will come up with new ways that surprise you. So text strings in particular are extremely flexible. I made this to make stories, but my users showed me that it can make like ASCII art. It can make SVG art, because SVG is just text. So it's like it can make HTML as text, SVG as text, emoji as text, JSON as text. Hey, wait, wasn't Tracery made out of JSON? And now things get weird. So this is a generator that generates generators that generate generators. And you can go as far as you want on this. So you can have, this is an art-bot colony that I presented some other places, asked me for demo at some point. There are art colleges, which are generators for art bots. Art bots are whittle creatures that have generators for SVG art. And so this is something that is pooping out little content generators that are each generating different styles of content, and they can argue with each other and have opinions about each other's artwork. And like each generator can in fact have multiple generators. So you can have an artist that goes through their blue period and then like learn some techniques from like an ellipse bot and then gets into like a really ellipsy place. But yeah, the goal here is to use data structures, make lots of content, have safe and sane data structures that allow you to not hurt yourself. Have a lot of fun making tons of content. Making content is like the best part of, well, my favorite part of this stuff. And you can find more stuff about Tracery here. That's the fashion generator. There's the fashion. And are there any questions? Yeah.
Have you ever heard of tangled generator? Because reminds me a lot of popular
Okay, no, there's been a ton of grammar-based generators. I think Orteal even has one, the cookie clicker guy. A lot of them, though, have been hosted, and so you can't actually like bust it out and include it in like a game. So I think that's one of the things that this became useful for, is that like it's just, you can add it into stuff and it doesn't have to be a big deal. Yeah?
So Emily Short and others have like kind of built some like plugins for doing like dialogue and conversations and interactive fiction, kind of generating it.
Mm-hmm.
I was wondering, do you see like a path to kind of like move Tracery a little more in that direction of having kind of like running themes in the conversation, or like trying to, I don't know, maybe you can already do this, but like having kind of like sort of like long-term state kind of threaded through many different generations?
Yeah, so the ones that I've needed to do that with, what I use is I still use Tracery to generate the text, but there's no reason that logic has to be in Tracery. That logic is just plain JavaScript. And then because those data structures are just JSON, I can, well, and they're JavaScript objects once they're slurped in, I can like rewrite symbol rules. So if they start discussing something, then I can push a value to that symbol rule. I can pull values out of the symbol rule, and the tracer grammar just becomes a whiteboard. Yeah.
So you
were talking about like one of the nice things about it being JSON is it's easy to copy and paste. It seems like there's an opportunity there for like curated ontologies. Is there any effort to have like, you know, obvious things like color, where maybe I want cardinal colors, maybe I want all colors, you know, and then I can have other things like I want HTML tag meets and so forth.
Yep.
But it would require trusted sources.
Yeah, so Darius Kazemi's Corpora is a really good source of that sort of stuff. Some people are trying to like go ahead and like directly Tracery format that. So it's like, it's a GitHub repository where people put in lists of all the US presidents, like all of the Pokemon, all the colors, etc. I found actually the color example is my favorite one because I found that it's the least useful that I expected it to be, because if like it's how you add flavor to your story. If I'm writing a Jane Austen simulator, the colors that I want are like jonquil and ecru and like daffodil. But if I'm writing the Lovecraft one, I want squamous or like whatever 18 different words he has for like slightly muddy purple. Just dropping red, green, and blue into those situations actually would be like it would kind of lobotomize your story, or at least it would cut out some of the fun bits. That said, like doing gender with Tracery is a real pain in the ass. And then for my restaurant generator, I tried to do French nouns and adjectives, and they have gendered adjectives, and that turns into a giant, like it's basically the Tracery version of the giant if statement. So like if somebody comes up with you like this is a little bit of Tracery buffoonery to like automatically like push a gender and like keep track of that, like those sorts of things might be useful.
Well, that's fine.
Okay, that's fine.
That's